Okay, we'll already discuss about partial differential equation of first order. Okay, various methods also be discussed, like as Lagrange method and Chapman's method. Okay, these methods are already discussed. These methods are used to find a partial differential equation of first order. Remember that Lagrange and Chapman's methods are used to find partial differential equation of first order. Okay, and in case of linear partial differential equation, we use suppose we use Lagrange method, and for nonlinear partial differential equation of first order, we use Chapman's method. And today I am going to discuss about partial differential equation of second order. Okay, and text message. Okay, then we going to discuss about partial differential equation of second order. Okay, for the first order partial differential equation, we consider the differential equation like as partial differential equation like as f of x, y, z, comma p, comma q. Okay, where x and y are what? These x and y are independent variable and z is dependent variable. This is dependent on x and y, and p is what? P is what? Del y by, oh sorry, del x by, del z by del x, and q is del z by del y. Okay, here suppose this is also same, but here we discuss about second order. Okay, so an equation is said to be order 2 if it involves at least one of the differential coefficient like r. Here we consider r. R is what? Del 2 z by del 2 x. Remember this thing. And s is what? Del 2 z by del x del y. Because here we are going to discuss about second order. Okay, in the first case we discuss p and q. P is what? Del z by del x. This order is 1, but here we are going to discuss about second order. So the partial differential equation consists at least one of the differential coefficient which has order 2. Okay, so this is considered as, suppose r is what? Del 2 z by del 2 x squared, and s is what? Del 2 z by del x del y, and t is what? T represent the del 2 z by del 2 y. Okay, that means what? Differentiable y in 2 times. Okay, partially differentiate with respect to y in 2 times. Okay, and here P and Q are what? P here P is also same. P is what? Del Z by del X, and Q is what? Del Y by sorry, del Z by del Y. So a partial differential equation of second order can be written in this form: f of x, y, z, comma p, comma q, comma r, comma x, comma s, comma t. Here r, s, and t. R, s, and t what? It is a differential coefficient of order 2. Okay, so remember these things. For the first order differential equation, the equation is look like as x comma y comma z comma p comma q. Okay, q equals to 0. And for the second order differential equation, the second order partial differential equation, the equation is look like as in this form: f of x comma y comma z comma p comma q comma r comma s comma t. Here also x and y are independent variable and z is dependent. Okay, and the most general linear partial differential equation of order 2 is two independent variable x and y with variable coefficient is of the form. This is what? This is the linear partial differential equation of order 2. R. Here small r represent what? Small r is del 2 z by del x square. Okay, del 2 z by del x square. And R, S is what? Small s. Small s indicates what? Del 2 z by del x del y. And small t. Small t indicates what? Del 2 z by del y square. That means they differentiate 2 times with respect to y. Okay. And here p, small p is what? Small p is del z by del x, and q is what? Del z by del y. Okay, here capital R, S, T, P, Q, comma Z, comma F are functions of x and y only, or not all the terms are zero. It may be some constant also, it may be some constant, or it may be some functions of x and y. Condition is this one: R, capital R, S, capital S, capital T, capital P, capital Q, and capital Z, capital A. These are functions of either functions of x and y only, or constant. Okay, but one condition is that not all these terms are capital R, only capital R, capital S, capital T cannot be, all these three terms cannot be zero. If it one is all these terms R, S, T. If all these terms, we cannot get the partial differential equation of second order, because R, S here. If suppose R is 0, one can be 0. Suppose R, capital R may be 0, capital S may be 0. But all the three terms, small capital R, capital S, capital T cannot be 0. If suppose one of, if suppose all the three terms capital R, capital S, capital T is 0, then what happened? Can you tell me? If suppose this one capital R, capital S, capital T is 0, then equation can be look like as what?
0, ma'am.
Hello?
Yes, ma'am.
If suppose capital R, capital S, capital T is 0, then equation can be look like as what?
Like 0, ma'am. All will be 0.
Hello? Yes, speaking.
It will be 0, ma'am.
If suppose these are 0, then this term will be automatically 0. The second term s
Yes,
into s, this term is also 0, and this term is
is
also 0.
0.
Okay, but see that we consider what? Second order partial differential equation. Second order partial differential equation means what? It involves at least one differential equation of order 2. Okay, so here see that small r indicates what? Del 2 z by del x square, and small
Right.
s is what? Del 2 z by del x into del y, and small t is what? Del 2 z by, this is not del 2 y, del y square. Okay, here see that the order of this one is what? 2. But if suppose all the uh, this capital R, capital S, capital T, if all that three terms are 0, then we cannot get a differential coefficient of order 2. So it is not a partial differential equation of second order. It may be look like as, it is look like as what? First order partial differential equation, because here p, small p indicates what? Del z by del x, and small q indicates what? Del z by del y. This is what? It is a first order partial differential equation. So if we consider capital R, capital S, capital T equals to 0, we cannot get a partial differential equation of order 2. Okay? Understand? Have you understand?
Yes, ma'am.
So condition is what? So these are this capital R, capital S, capital T. All the three
All
terms cannot be 0. Okay, one of these three terms can be zero, but all the three terms cannot be zero. Okay, so here's condition. Remember the condition: capital R, capital S, capital P, capital P, capital Q, capital Z, and F are function of, it may be either function of x and y only, or it may be constant. But one of the condition is that this R, S, T cannot be zero. Okay, can you guess the difference between first order partial differential equation and second order partial differential equation? Hello? Hello?
Yes, ma'am.
Can you guess the difference between first order partial differential equation and second order partial differential equation?
Yes, ma'am.
Tell me.
Like in second order partial differential equation, ma'am, R, S, T all cannot be zero, ma'am.
In first order differential equation is look like as what? For first order partial differential equation is look like as what?
X, Y, Z.
Tell me. For first order partial differential equation is what? F of x comma y comma z comma p comma q equals to 0. Okay, remember that
Yes,
equation is what?
yes,
F of x comma y comma z comma p comma q equals to
Q
0.
zero.
Okay, where small p and small q is what? These are some um, functions of x and y, or it may be constant. In some cases it may be constant. Or this one is what? P. Small p is what? Del z by del x. Remember this. And small q is what? Del z by del y.
Del Z by
I have
del.
repeated the thing
Del
because it is necessary. How can we find the difference between first order partial differential equation and second order partial differential equation? For first order partial differential equation is this one: f of x comma y comma z equals to p comma q. We stop here. Okay, where p is what? P and q are functions of x and y only, or it may be constant. Okay, and p is what? Del z by del x, and q is what? Del z by del y. And here x and y are what? Independent variables are what? Independent variables are what? Independent variables are what?
X and Y
X and y, and z is
dependent variable.
dependent variable. Okay, and for the second order partial differential equation, it is look like as what? F of x comma y comma z comma p comma q. All the terms are look like as the first order partial differential equation, but here for the second order partial differential equation we include other terms. Okay, because second order partial differential equation involves a differential, at least a one of the differential equation which is order 2. So we here we include r comma s comma t. Okay, where small r is what? Small r is del 2 z by
Two
del x square. Okay, and a small s is what? Del 2 z by del x del y, and small t is what? Del 2 z by del y square. Okay, understand? Can you understand?
Yes, ma'am.
Okay, and okay, then fine. Okay, and also remember this equation. This equation represent linear partial differential equation of order 2. Here, this one capital R, capital S, capital T, and capital P, capital Q, and capital Z, capital F are functions of X and Y, or it may be constant. And one condition is that capital R, capital S, capital P, all the three terms cannot be zero. Okay, one of the term may be zero, but at the same time, all the three terms cannot be zero. Okay, now see this example. Here, suppose solve R equals to 6x. Remember then, when P and only P and Q are arise, then uh, you should have to think that this one is first order partial differential. If only P and Q arise, the uh, coefficient suppose P and Q arise, then your consideration one is what? This is the first order partial differential. When R, like a small r, small s, small t arise, then your consideration is what? This is the second order partial differential. Okay? When only P and Q comes, then you have to
Okay.
consider this is the first order partial. Okay? Here first order partial differential equation we use suppose the Lagrange method surface. Okay? So in the case of Lagrange method and surface method, the equation is of the form P and Q. Okay. When suppose R
Yes.
comes, then you have to think that this one is second order partial differential. If suppose small r, small s, small p comes, then you have to think that this one is second order partial. Okay. Here suppose this one example is this one. Solve r equals to 6x. Solve r equals to 6x. So r is what? R means
R
del 2z by del
is
x square.
X square.
Okay. We want to solve this equation. That means we have to find the value of z. Okay. Here suppose r is given. R means what? Del 2z by del x square, which is equals to 6x. So first you have to integrate this term. When we integrate this term, then what you get? If suppose this is the second order partial differential. So when we integrate this one, here integration of del 2z del x square. Del 2z del x square is what? Del 2z by del x into del 2, del z by del x into del z by del x. Okay? And now tell me, integration of dx is what? Integration
It's
of
X
dx
square.
is what?
X, ma'am, X.
Integration of dx is x. Okay. Here see that this one is what? D del x. Okay, del x. See the denominator. Here this one is what? Del x square. Okay. Del z by del x square can be written as del z by del x into del z by del x. Okay. So integration of del z by del x is what? We know that integration of dx is 1 x.
Yeah.
So integration
X.
of del z by del x will be what?
X. Only.
What? Tell me.
X, ma'am.
Yeah, it is x. So when we integrate This one. Integrate this equation, then this will be what? X del z by del x. Okay, understand?
Yes, ma'am.
And in the right hand side, this see that this one is what? 6x. If we integrate this term 6x, because 6 is what? 6 is constant, so it comes outside.
X by
Okay.
2.
And this one will be what?
X square by 2.
X square by 2. So terms is automatically what? 3x square. Okay.
2 square.
And phi 1 y. This one is what? This one is constant. Because in the general integration, we write as suppose integration of dx equals to what? X plus c, where c is what? C is constant. Okay, but here see that for the partial differential equation case, here we consider constant is considered like as phi 1 y. Okay, phi 1 y. This is a constant because see that for the partial differential equation, when we differentiate with respect to x, then y other variable y is considered as constant. Okay, I have already told you. When we differentiate with respect to x, then y other variable y is considered as that constant. So constant term is write as in this form phi 1 y. Okay, here we are not write this one is c. In the general integration, we write this term is constant is c. Okay, we write for the constant term we use the c. Okay, but in here in the partial differential equation, see that this one is what? This one is x. Okay, this one is x. So other variable is what? Other independent variable is y. So it is what? It it is considered as constant. So constant term can be write as phi 1 y. Okay. Here see that we get x into del z by del x. Okay. And therefore we have to integrate this term again. Okay. To get the value like as in terms of z. Okay. Again we integration this term because in this step we have not get the value of z. To obtain the value of z, we have to integrate this equation again. Okay, when we integrate
Yes.
this term, then what will happen?
X will remain constant, ma'am.
When we integrate this one, should be x is
It would
comes in outside. This one will be what? Integration of del z by del x, and this will be what?
that.
Z. Okay.
Yes, ma'am.
Will be x this is equal to when we integrate this term again, then 3 is thing is
Constant.
constant, so it comes in the outside, and when we
3.
integrate x square, the value will be what?
X cubed by 3.
X cube by 3. So here this term will be what? X cube.
X cubed.
Okay, and for this term, see that this one is constant. Okay, this one is
Yes.
constant, so it comes in the outside. Uh, this one phi 1 y, this one is constant, so when we integrate this term, this comes outside, and other term will be what? Integration of dx, so it will be what? X into phi 1 y plus again constant what? Phi 2 y. Okay, where this is the required solution. Okay, that means from r you have to obtain a equation in the form of z. Okay,
Ma'am, how that X came, ma'am?
what?
How that X came, ma'am?
This
X
one,
phi 1 by, yeah,
this one.
X phi 1. Yes, ma'am.
Because see that this one is what? Phi 1 y. This term is what? This term is constant.
constant.
Okay, this term is constant. So it comes in the outside. Then other term is what? Integration of del
X.
x.
I mean,
Integration of del x will be what?
X.
Integration of del x will be what?
X, ma'am.
X. So it is what? It is
X 5 1.
x phi 1 y, because this is constant, so it is comes outside. And for this integration also we have to add another constant. Okay, so other constant is what? Phi 2 y.
Y.
Okay,
Yes, ma'am.
can you understand?
Yes, ma'am.
Okay, that's fine. And see this problem, this is same as, but here a is also multiplied. A is also multiplied. A r equals to x into y. Okay. First, write the equation in terms of r. If we write this equation in terms of r, then equation is look like as what? R equals to 1 by a into xy. Okay. R equals to what? 1 by a into xy. Okay. Understand? Hello?
Yes, ma'am.
Okay. Then see that this one is del 2z by del x square equals to 1 by a into x square. So our aim is to what? Our aim is to find a partial, find a equation in terms of z. So you have to integrate this term. Similar process is used here. First integrate this one. When we integrate this one, then term is what? X will become, when we integrate these terms, this one will be what? X del z by del x equals to, when we integrate with respect to x, then this will be what? 1 by a into y. Y is considered as constant, so term will be what? Term will be look like as x square by y. Okay? When we integrate this one, then this part will be what? Del z by del x. If we integrate one time, then one, then we get del z by del x. And this one will be what? Y is considered as constant, y by a, x square by 2 plus phi 1 y. Okay, so here phi 1 is constant. So to obtain the value of z, we again differentiate this one. Sorry, we again integrate this term. When we integrate this term, what will get? This will be z. Z is what? Y by a. This one will be what? X cube by 6. This is not 3. This is x cube by 3. And so for this term, we will integrate with respect to x. So this will be comes as x into phi 1 y plus phi 2. Process is similar. So this is the required solution. Okay. Write two problem as your homework. Each one. R equals to
2y square.
y square. R equals to y square. That means this one will be R means what? Del
R is
by del x square.
square.
Okay. First integrate with respect to x. So first term will be what? Del z by del x. equals to twice y square because y is considered as constant, so term will be what? X will be comes. Y is y square into x. Okay, plus
X.
phi 1 y. And next, this term will be what? Del z by del x. For del z by del x, we integrate again. After integrating with respect to x, we get z equals to some term. Okay, and try to solve that. And also write this equation also. So t equals to sine of x, xy. T means what? T means del 2 z by del y square.
Y square.
For yeah, T means what? Del 2 z by del y square. For this
Del
equation, you have to integrate with respect to y, not
Y.
in x. Because for r, this one is what? Del z
Del
2z by del x square. So we integrate with respect to x. But here,
X.
this one is t. So
Y.
t means what? Del 2z by del y square. So you have to integrate with respect to y. Okay? Hints is this one. I give the hints and try to solve this quickly. Okay? Have you any doubt?
Ma'am, can you go a little bit up, ma'am?
What?
Second question, ma'am. Second question.
For second question.
No, ma'am. I have one doubt, ma'am. In second problem, we solved one problem. No, ma'am. Example two.
Example 2. In
Yes,
example
ma'am.
2, you have doubts.
Yes, ma'am.
See
Ma'am,
this.
while integrating del square z by del x square. No, ma'am. Why x is not coming here, ma'am? It is only del z by del x. No,
This
ma'am.
one,
Yes, ma'am.
del 2z by del x square.
Yes, ma'am. While
Because,
integrating, we should get.
yeah, this is del z by del x into del z by del x. When we integrate
Yes,
which one? When we integrate with respect to x, then 1 del z by del x is omitted. Then this only del z by del x comes. And the in next part, this one. Here also see that here this should be del z by del x, not x. X is not comes in there. There is a some printing mistake. This should be only del z by del x, not x into del z by del x. Okay, because this is del 2 z by del x square can be write as del z by del x into del z by del x.
yes,
Understand?
yes, ma'am.
When we integrate with respect to x, then we get first we get del z by del x. Here x is not come. X will not come.
Okay,
Okay?
ma'am. Yes, ma'am.
There is a printing mistake. This should be del z by del x. After that, when we again differentiate this term, then when we again integrate this term, then we get z, not
That
x.
only. Yes.
Okay.
Okay, ma'am.
Now clear.
Yes, ma'am.
Okay. Similarly, try to solve these two problems. Okay.
Okay, ma'am.
Okay. Then for today, I will